All right, 4.3b, talking about finding exact trig functions. So we're still working with trig functions on the unit circle and then finding exact trig functions. We'll try to do that. Okay, so first thing we want to talk about here when finding exact trigonometric functions for theta, we know also that you're going to need a reference angle. Okay, so theta is going to be your reference angle. You're going to need to find that to do these problems. So you need to find that. Okay, and then what we want to do is we want to find the trig function for theta. So whatever we're dealing with, whatever that reference angle is, and whatever the information given is, we're going to use the appropriate trig function: sine, cosine, tangent, cosecant, secant, cotangent. All right, now you may have to check back in your notes, back to the old 4.1 highlight reel notes, to find the exact trig values, unless you've memorized them, right? Unless you have those memorized, what those exact values are: square root of 2 over 2, 1/2, based on those common angles, 30, 60, 90s, 45, 45, 90s, and what they are. So go back to 4.1. There's a chart listed on there. It's also on page 242 in your textbook, so you can look at that as well if you need it. All right, so now when we want to determine the sign, whether it's positive or negative, that's the next thing we're going to talk about, is we determine the sign based on the original angles quadrant. So where are we at? What quadrant are we in will determine the sign, whether it's positive or negative. So, and again, looking at that quadrant, it's the sign of the trig function is determined by its terminal side. Okay, we know the initial side is going to be an axis, the x-axis, and so its terminal side, whatever that lies in, will be the quadrant that we decide. Okay, so a couple charts here that'll help you a couple different ways, but let's just I'm going to skip this first one and come back to it and then help us out. Okay, after we fill out this first chart. Okay, so this first chart, if we just list the quadrants here, as this is quadrant 1, right, and then we go kind of counterclockwise, this is quadrant 2, and this one would be quadrant 3 and quadrant 4. Then I can find out what those values are for each one just by knowing a couple things. So if I just put sine, cosine, I'm just going to put sine, cosine, and tangent in here, because remember, the other ones are just reciprocals of that, right? Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So those signs are not going to change just because it's a reciprocal. So a positive, negative won't change at all. Okay, so as you're writing it down, just remember, and you might want to write this down too, but how do we know that these signs are what they are? Okay, so if we are in quadrant 1, if you think about that, where we're at, sine is going to be positive, cosine is going to be positive, and tangent is going to be positive. Okay, why is that? Okay, if I just draw a quick graph here, if we're in quadrant 1 and I have my triangle, right, my x is going to be positive and my y is going to be positive. My r I know is always positive. So in that case, whether I do, sine is y over r, so I know that's going to be positive. Okay, cosine is x over r, so I know that's going to be positive. And tangent is y over x, so everything's going to be positive there. Think about it in the other way. If we look at, say, the next quadrant, quadrant 2, if I have that, if I'm over here, well, I've got my x going this way, my y going this way, and my r. Well, I know my r is positive, my y is positive because it goes up, but my x is going to be negative. So again, looking at that, in these cases, for quadrant 2, my sine value is still going to be positive. Cosine then would be negative because, my sine value is going to be this here over this. So it's going to be positive over positive. Cosine is going to be x over r, which would be negative then. And tangent is also going to be opposite over adjacent. So tangent would be negative as well. Okay. So the same ideas kind of follow with the next ones as well, just to keep in mind. I just want to show you why we're getting these signs. So for negative, for quadrant 3, sine is going to be negative, cosine is going to be negative, tangent is going to be positive. Tangent is going to be positive because both your y and x are negative. So your y and x are negative. That's why cosine and sine are negative. But in that case, your ratio for tangent will be positive because a negative divided by a negative would be a positive. And over here, your sine would be negative because your x would be negative. Or x would be, or your y would be negative there. Cosine would be positive because that deals with the x, and x would be positive in this situation. And tangent would be negative because we'd have a negative over a positive for y over x. Okay? So that kind of helps us. Now, the other thing I want to point out here is use the reference angle when we're doing this. Okay? Find the reference angle. It makes it easier to say, all right, what am I doing? I don't want to use, pi over 4, or I don't want to use negative 210 or negative 210 degrees when I can use a reference angle of 30, okay, or 50 or whatever it is. But use that, and then you can determine what the sine is going to be based on that. All right, so taking all of this stuff from these here, I can kind of fill out a different type of chart. It's the same information, but some people are going to like it a little bit different. So I know in quadrant 1, so remember, I'm starting over here, quadrant 1, my sine or my secant is going to be positive. So just go around counterclockwise, positive in quadrant 2, and it's going to be negative in quadrants 3 and 4. Cosine or secant, remember again, they are reciprocals of one another, so their signs are going to change. So cosine is positive here in 1, negative here, and then it goes negative in quadrant 3, positive in quadrant 4. And then tangent or cotangent is going to be positive, negative, positive, negative. Okay? And again, you kind of look at that, how it makes sense, right? Because we know this is y over x or x over y, depending on what we're dealing with. So positive, 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 negative, negative, positive. Positive times a negative would be, or positive divided by negative would be negative. Negative divided by positive would be negative as well. So it kind of makes a little bit of sense there. Okay? All right, so let's get to this. Let's practice with this. So we want to find the exact value. So you're going to want to have either the chart on page 245 or 242. They're both there. I think there's one on page 245, sorry, page 245, or your 4-1 notes, okay? 4-1 notes has a chart, and page 245 has the chart with those values, okay? So let's look at this, sine of 135. Okay, so I want to use the reference angle, right? I don't want to use 135. I want to use a reference angle, so I'm using acute angles that are always positive, because that's what I have on the chart. I have 45, 60s, and 90s, or 45, 30s, and 60s, okay? 30-degree angles, 60-degree angles, and 45-degree angles. So that's why I want to use the reference angle here, because that's what I'm going to be dealing with. 30s, 60s, and 45s, okay? So that's what the chart has. So use that chart. All right, so sine of 135. I don't want to use sine of 135. I want to use the reference angle. So if I look at what 135 is, its reference angle is going to be 45. But if I think about this, this is going to be, 135 is going to be in quadrant 2. So that's going to make it positive, right? Since we're dealing with sine in quadrant 2, we're dealing with positive. So I can keep it positive. I'm just going to worry about the sine. And now I just got to look at my chart and say, well, the sine of 45 is square root of 2 over 2. And that's just by looking at my chart here or my 4-1 notes to get the exact value. The hardest part here is getting the correct reference angle and getting the sign. So cosine of negative 150. All right, so if I look at this one, I'm looking at cosine of negative 150. If I go ahead and try to find the reference angle, it's going to be cosine of 30 degrees. But I put a little space here because where are we lying here? Okay, if we're sitting here, here's my XY axis. Cosine of negative 150 is going to put me in this quadrant here, right? So I'm going to be in quadrant 3, which means that cosine is going to be negative here. So I can put a negative sign there out in front. And so that means I'm going to use that chart and say, well, what's cosine of 30? Cosine of 30 is square root of 3 over 2. But I know it's negative because of that. So moving on to the next one. Okay, so we have cotangent of 7 pi over 3. Well, this is tricky, so I don't really want to mess with this too much. So I don't want to mess with radians, so I'm going to multiply it by 180 over pi and put this into degrees. Okay, so that's going to equal the cotangent of 420 degrees. Okay, so I still want to find a reference angle here, 420. I don't want to use that. So that's going to equal 60. Okay, cotangent of 60 degrees. All right, now, if I do that again, if I'm looking at this angle, 420 degrees, right? I'm going all the way around is 360. So then I'm going another 60. So that's how I'm getting that reference angle of 60 degrees. Now I'm dealing with cotangent. So I'm in quadrant 1, right? So quadrant 1. Now I'm talking about tangent here because I don't really have, my notes don't really have the ratios for tangent, I don't think, unless they do in 4-1. But if I go tangent of 60 degrees, I know the chart on 245 just has sine, cosine, tangent. So it's quadrant 1. Tangent is, if we look up here, tangent is positive in quadrant 1. I shouldn't make it a negative. I should circle it. Okay. So I know we're in quadrant 1, which makes it positive. So I can keep it like that. Tangent of 60 degrees is the square root of 3. Okay. So that's tangent though. So now I need the reciprocal of that. So cotangent of 60 would be 1 over the square root of 3, which would equal the square root of 3 over 3. Okay. All right, let's keep rolling on here now. Tangent of negative 135. Okay, I guess I should say that the chart on page 245 only has sine, cosine, and tangent, but your 4-1 notes have all 6 trig functions. So you'd be able to kind of see those from your 4-1 notes, depending on what you had. So you wouldn't necessarily have to do this part here if you're using your notes on 4-1. Okay, so tangent of 135. So, or negative 135. So again, just finding that reference. If I'm going negative, I'm going this way, I'm going to be in quadrant 4, right? And that's going to be a 45-degree angle. So I'm looking at quadrant 3 for tangent puts me positive. So again, just looking up here, tangent 3, positive, okay? So now I can say, instead of using negative 135, I can say, well, I know that tangent of negative 135 would equal tangent of 45. And that way I can go tangent of 45. I can just use my notes and my chart and say the tangent of 45, my exact value is 1. All right, that helped out. Now these last two are a little tricky because, again, they're in radians, but we just got to figure it out and put them up to turn them into degrees and then go. So 11 pi over 6 If I multiply by 180 over pi, I'm going to get 330 degrees. And so now I'm looking at, where are we at? 330. Well, that's going to put me in quadrant 4, right? 330 right here. Okay, and that's going to give me a 30-degree angle here. So I'm looking at the cosecant of 330 degrees equals basically cosecant of 30 with the reference angle. But what quadrant are we in? We're in quadrant 4. So what is cosecant in quadrant 4? I look up here. All right, cosecant in quadrant 4 is negative. So I'm going to use a negative out in front. It just tells me the answer is going to be negative, whatever that is. Now, I can go ahead and I can do sine and do the reciprocal, but if I use my notes here, you can jump to that I know that this is going to be -2, because it'd be the sine of 30 would be 1/2, or -1/2 in this case. The reciprocal would be -2. Okay, and the last one, secant of 3 pi over 4. So again, multiplying by 180 over pi gives me 135 degrees. All right, so if I just draw that really quick, 135 is going to take me over here to quadrant 2. It'd be a 45-degree angle reference. So I'm in quadrant 2, and I'm dealing with secant. So secant of 135, we know, is the same as secant of 45, but we're in quadrant 2, and secant in quadrant 2 is positive. Oh, I'm sorry. Secant in quadrant 2 is negative. Okay, so I'm using secant of quadrant 2 is negative. So I can put the negative sign in here. And then, again, I could use cosine and do the reciprocal, but I could just use my chart here and say the opposite, or negative secant of 45 degrees, is going to be the opposite of what I have in that chart. The chart says negative square root of 2, and I say negative square root of 2, because it's negative. Okay, so next part of this section here is the unit circle. So when we talk about the unit circle, we're always going to use a radius of 1 here. Okay, use a radius of 1, and this is going to be centered at the origin, so our circle. So this is going to mean that basically r is always 1, and we already know that r is going to be positive. So r is always positive 1 here, because it's the radius. All right, so that makes things a lot easier for us as we go. So what does that mean? We have this unit circle, and I will give you a sheet with all these values on there. Obviously, you can use the notes, or you can use the reference sheet I'm going to give you. But what that means is, because r is always positive 1, so that's what I'm trying to say here. So if you have a sign, they use sine t. I don't know, they just use t as a point on the line, on the circle. Okay, so if we just say that we know that sine of t, they give us t, we know it's equal to y over r. But because r is always 1, we can basically just say that sine t is y, because it's going to be something over 1. Same thing can be said for cosine of t, right? So cosine of t is x over r, but basically it's just x because we know r is equal to 1. Tangent is going to be a little bit different, because tangent is going to be still y over x, so we can't really change that. We'll have to have a ratio. And the other 3 are just the reciprocals of those again. Just put t in there. This is what they use, the exact angle there. So in this case, because we know it's y for sine and cosecant the reciprocal, it would be 1 over y. And then we could put secant would be 1 over x, and cotangent would be the reciprocal of tangent, so x over y. So I want to have those down to know. Now it's pretty simple. Once you have these ratios here, then we can just point to the point on the unit circle and whatever value we're talking. Maybe it's just the y, maybe it's just the x, maybe it's y over x, but or maybe it's one of these three down here, but use what they're giving you and use the values on the unit circle. Again, I'll give you a reference sheet with this on there. Obviously, it's also on your notes that you're filling out right now. So let's go through these. Find the exact value of each expression. If it's undefined, write undefined. All right, so pi over 4. So let's look at pi over 4 here. Pi over 4 on the unit circle. If I find that value on the unit circle, here it is, pi over 4. So here's the point that I'm dealing with. Square root of 2 over 2, square root of 2 over 2. So pi over 4 equals the square root of 2 over 2, comma, square root of 2 over 2. Now, since we're dealing with cosine, and we look up here, we said, well, cosine is just x. So really, I'm just looking at this piece right here, and I know that cosine of pi over 4 then is equal to square root of 2 over 2. Okay, so just using that chart. Now it's a little bit different because we have cotangent. All right, so cotangent of 210. All right, so here's where you kind of have to go back. And actually, the unit circle has 210 in there. So 210 is right here with 7/6 pi. They're the same thing. So if I look at that, that's going to correspond with this point right here. So I can jump to it and say cotangent of 210, or I should say 210, is equivalent to this point here, square root of 3 over 2, comma, negative 1/2. Okay, so we're using basically those unit circle values, those exact values from that we did on the first page of these notes. And now I look at cotangent of t is x over y. So I'm just going to take this x value, put it over this y value. So cotangent of 210 is square root of 3 over 2 divided by negative 1/2. And as you work that out, you'll end up just getting the square root of 3 as we simplify. All right, tangent of 270. Okay, so 270 is going to go along with the point. Just look up at the circle, 0, negative 1. Okay, and we're looking at tangent. Tangent of t is y over x. So in this case, I say, okay, y is negative 1. So tangent of 270. Y is negative 1. X is 0. So can't have 0. So we'd have undefined. That one. All right, let's keep rolling. So 11 pi over 6. So this gets a little bit tricky because we have to find where 11 pi over 6 is. Well, if you remember, if you can kind of look at the fractions, well, it's on the sheet. It's already there. Good. So we're good. We're right here. So we're using this point. All right. Sometimes you have to do a little work. I think the last two we had to do a little work to make an equivalent number on the unit circle. So we have that value is equal to square root of 3 over 2 and negative 1/2. So as I keep going here, looking at cosecant is 1 over y, cosecant of t. So it's going to be 1 over negative 1/2 because that's the y value here. And again, simplifying, multiplying by that negative 2 gives me a negative 2 for my answer here. All right, 3 more. Let's roll through them just so we are familiar with some, because these last couple, you actually have to find like an equivalent value. All right, so, or a coterminal angle. So 13 over 4 pi. Well, this is actually going to be, let's use red now. I'm just getting tired of it. Purple. So this is actually going to be 5/4 pi as a coterminal angle. Okay, how so? Well, 13/4 is tough to get to. So let's go back up to the circle and look. Remember, 2 pi is a full rotation. So if we're talking about fourths, then we could assume 8/4 is right here, or 2 pi would be 8/4 pi, right? So I really need to go 5 more. So 1, 2, 3, 4, 5. So that's how I got it equivalent to 5/4 pi there. Okay. The other thing I could do is just count all the way around the fourths, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I'd be here if I wanted to. Just got to count the fourths. All right. So now that I know that that's the same reference angle, I can use that point that we just found and say, well, that's equal to negative square root of 2 over 2, comma, negative square root of 2 over 2. And we're dealing with sine here. So sine of t is just equal to y. So it's just simply that value there, negative square root of 2 over 2. All right, cosine of negative 4/3. So now we're going negative. So I'm going to look at this part here, and I'm going to count. I'm going to look and say, well, if I'm going negative 4/3, so this would be my starting point. All right, 1/3 would be here. I know it says 11/6, but 6 and thirds are together. So we go 1, 2. Oops, my bad. I messed up on that. Let's go in the other way. Let's go in with 6s. So here would be my 1/3. Okay. 2/3 would be here. 3/3, right? Because 3/3 is equal to 1 pi, right? Okay. And then if I'm going 4/3, that would take me up here. So it's actually going to be equivalent to this, 2/3 pi. So let's keep going then. So I know this is really a positive 2/3 pi if we're looking at the reference angle. So if I was coming from it from this way, it'd still be a positive 2/3, right? So I'm looking at the reference angle being coterminal there. And so now I can say that 2/3 pi is equivalent to this point here. And where are these getting these points? They're getting these points from those exact trig functions from the previous part of this section, the first page. And now we're dealing with cosine. So that's just going to be equal to x. So I know my answer here is negative 1/2. Okay. And the last one, we've got 15/6 here, right? So now, again, I'm going to have to count the circle. I'll save that work for you and say it's pi over 2. That's the equivalent. And you can count that out if you want to using 6. But that is equivalent to the point 0, 1. So tangent of t, we know is y over x. So it'd be 1 over 0. Can't have 0. Undefined. Okay. So a lot covered there, but it's not that bad if you just break it down into what you need to do, figure this stuff out. Okay. If you have questions, you got to ask them, and I'll be ready to help you. Have a great day.